Alright, so solving right triangles. Now, there's a lot of situations that you're going to get. Some your basic ideas that you're going to use. And this is for any right triangle. That's angle A, that's angle B, angle C is your right angle. That's side A, side B, and side C. So one thing that you always have at your disposal is the Pythagorean theorem, where it's a squared plus b squared is equal to c squared. So we can't forget the Pythagorean theorem. And a lot of times when you're going to use this is you know two sides and no angles. So if you know two of the sides of your triangle, say you know like B and C, and that's all you're given. You can find the side A just by applying the Pythagorean theorem. A squared plus b squared equals c squared. Make sure that everything's labeled nice and neat. If you're given a triangle with just numbers in it without any points, make sure, I would always recommend labeling it A, B, and C, where A and B are your acute angles. Second thing that you need to know, before we get into the trig stuff, acute angles are complementary. So if I take the measure of angle A plus the measure of angle B, these two guys right here, they're complementary, which means they add up to how many degrees? Now 180, that's supplementary. 90. So 90 degrees. And the whole way we can figure this out, I'll do a little aside here. If I have, and I'll just say A, B, and C, capital A plus B plus C is equal to 180 degrees. But what's the measure of angle C? 90. So A plus B plus 90 degrees is equal to 180 degrees. If you subtract the 90 degrees, you get A plus B is equal to 90 degrees. So it's not just something that we make up, it's something that is a consequence of this being a right triangle. So those two acute angles, if you know one of them, so the biggest thing that we get from this is, for example, the measure of angle A is equal to 90 minus the measure of angle B, or the measure of angle B is equal to 90 minus the measure of angle A. So all we have to do is subtract the angle value from 90 degrees, and you can figure out your other angle, which is nice. So those first two ideas are the two, I want to say, non-trig ideas that we'd use. Everything else is going to be based off trigonometry. So use your trig ratios, and we'll use this when you know two sides. Oh wait, well, you know one side and an angle, not two sides. If you know two sides, then you get the third side, and you're going to do something else. If you know two sides, you're going to do something else. So if you know one side and one of the angles, then what you could do is you can build the sine, the cosine, or the tangent for whatever angle you have, and just using SOHCAHTOA, which is what we have here, you can set up this equation and solve it for the you could solve it for whatever side is missing. So you can actually figure out a second side if you know one side and one angle. So if you know one side, one angle, you're going to use a trig ratio to figure out what's going on. And then once you know one side, one angle, then you can go back and actually fit in the other parts. Once you know one angle, then you can use this idea to figure out the other angle. And then once you know two sides, you can use the Pythagorean theorem to figure out the third side. So a lot of stuff falls back into the Pythagorean theorem and this idea of 90 minus whatever acute angle you have is going to be the other acute angle. You can do it all using trig functions too. As soon as you figure out one angle, or you have the other angle, then you can figure out everything. And the nice thing is, if you know one side and one angle, you'll know the second angle. It's just 90 minus the angle. And you can use trig for everything. You actually don't even need to use the Pythagorean theorem. Now, the only thing that is going to get you an angle when you don't know any angles, so when you don't know any acute angle, we need to use the inverse trig functions, which would be the inverse sine of the opposite over hypotenuse would be equal to the angle, or the inverse cosine of adjacent over hypotenuse is equal to the angle, or the inverse tangent of opposite over adjacent is equal to the angle. So if you don't know an acute angle, use your inverse trig functions. So this is the basics. These are the things that you're going to need in order to solve this. So I'm going to go through and recommend different approaches for doing this. And I'll have those up on the website. I'll have a flow chart for you up there. And we'll kind of do this with examples. But these are the 4 things that you need to know. And honestly, you can pretty much get everything done using trig. Everything you can pretty much get everything done using trig, because you're gonna be given enough information to either set up sines, cosines, and tangents, or inverse sines, inverse cosines, and inverse tangents. and then you can kind of work from there. And I'm going to show you a couple ways that you can actually do this. So first off, any questions on the ideas that you're going to use, first and foremost? Alright, so I'm going to end this as kind of like part one. I'm going to give you a worksheet with all these different triangles, and then we're going to do a bunch of examples.